So in this video, I actually want to talk about two more interesting facts concerning the isodynamic points. Okay, so the first one, which we built in the previous video, and here they are, X15 and X16, and they are the common intersections of the three Apollonian circles. I'm going to leave a link up on the right hand side so you guys can go back to the previous video. So what are these properties? First of all, the centers of the three Apollonius circles are going to be collinear. So let's go ahead and draw those circles. So let's see, this circle here, the first Apollonius circle is known is being labeled here as lowercase c, so I'm just going to say center C. Okay, so here's the center of my first Apollonius circle. Okay, it must lie on the sideline BC because that circle has as diameter two intersections of the bisector at A with that side. So that center there, I'm gonna label the center here as, let's call this OA, 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 and I'm gonna make this guy appear with a red color right there. Now let's go ahead and I'll draw the center of the second circle, which passes through B. Here it is, and the circle is labeled D. I'm going to say OB is equal to the center of D. And where is that? That should be somewhere. It's over there. Let's make that come closer to us by tweaking this triangle. And let's make that be also red. So settings red. And finally, the center of the C Apollonius circle, which goes to the vertex C, and that's labeled E. So I'm going to make that guy be OC is the center of E. There it is. Settings, color red, red. Yes. So now what I want to see and I want to show is that these three centers are in fact collinear. So let's check that. I'm going to draw a line from OB through OC and make sure that, and let's make this line be, say, magenta or maybe green so it stands out a bit more. Yes. And let's make it be dashed like so. So are these three centers of the three Apollonius circles in fact collinear? Let's see if I can place all of them on the same screen. Yes, and yes they are. You can see here that OA, OB, and OC are in fact collinear, as circles in the same pencil should be, right? The centers of circles in the same pencil are all collinear. So they're on the same, as we said before, elliptic pencil. Their intersections are X15 and X16. Another really cool fact about the two isodynamic points is that they are inverses or reciprocals of one another with respect to the circumcircle. Let's draw the circumcircle of this triangle. So this is a circle that goes through the three vertices of the triangle A, B, and C. And let's draw this circle. I'm going to make it be just for, just to harmonize it with the triangle itself. I know this is boring, but I'm going to color it blue and make it be dotted as well. So here's a circumcircle of ABC. And I want to show that X16 and X15 are reciprocals of one another with respect to the circumcircle. Now, one cheap way to do this in GeoGebra is simply to say, okay, let me compute the polar of X15 with respect to the circle. So how do I do this? Polar. Let's find polar here. I probably went through it already. I'm just not finding it. It's over here, polar. Polar or diameter line. So what do I need to do? The instructions are select a point or line, then the conic. So I'm going to select X15 right here, and then this conic, the circumcircle. And my polar of a point with respect to a conic is a line, right? So here's the polar line. Let's go ahead and make this guy here have color red, and I can leave it solid for now. I don't want label. I don't want it to be labeled. I also don't want the circumcircle to be labeled. Get rid of that. I hate GeoGebra labels. And there it is. So the polar of X15 is going, with respect to the circumcircle, is a straight line that seems to go through X16. Okay, so what you want to know if X16 is the proper inverse of X15 is if a perpendicular drop from X15 onto the polar is at X16 as we want. So let's go ahead and draw this perpendicular. So I'm going to say perpendicular from X15 through this polar here. And indeed, you can see here that, as expected, the intersection of these two lines is in fact, let's make this guy be, I don't know. Yeah, we can make it be red, but I'm going to make it be dotted red. So this is a perpendicular drop from X15 onto the polar of X15 with respect to the circumcircle, which gives me the inverse. The foot of that perpendicular with respect to the polar is the inversive image or the inversion of X15 with respect to the blue circle. And indeed, we're seeing here this nice property that the second isodynamic point and the first isodynamic point are inverses with respect to the circumcircle. And we're also seeing that the three Apollonius circles are collinear. All right, so that's what I had for this video. See you on the next one.